Hey again, everybody. Mr. McComb here, once again coming to you for some science stuff. Hopefully you enjoyed and learned a little bit from our last video with food chains and food webs. And today we're going to get into another sort of diagram that tells us a little bit about ecosystems and how the energy is moving from one level to another, or from producers to consumers to other kinds of consumers. These are called energy pyramids. So just 2 pages today. But since this is probably a newish concept for you, or a new idea, I want to kind of walk through it with you here too. So we're going to talk about some of the big details with that and why these energy pyramids are useful. Kind of adds another level of detail to our understanding of how the energy goes. So when we talk about food chains and food webs, we talk about where the energy flows from one organism to another. And when we talk about energy pyramids, we're talking also about not just how the energy flows or where it flows, but how much flows from one to another. Okay, so we've got a couple good ones in here, and we're going to do one of our own that we might even see in our own neighborhoods that'll help us understand a little better. But on page 222 and 223, that's kind of, you should just have your book open, and we're just doing these today. First of all, really like this one, an ocean food, or sorry, energy pyramid. And we can make a food chain all the way up here, and we see our producers, like in this case, phytoplankton, which is kind of like algae and things that are plant type organisms that are in the ocean that use photosynthesis to create energy and start the whole food chain. And then they work their way up to these things like the first level consumers, which would be like krill and clams and other fish like this. And then up higher, we see bigger organisms like octopi, and looks like another kind of fish that's maybe like a salmon that would eat krill and things like that. And then up at the top, we have this one called a leopard seal in this case. Now, there's, of course, lots of other consumers in the ocean and lots of different organisms that live in there. But here we've got basically one, we could call this a food web if we connected all the different arrows and lines, but we could also say we have a food chain. If we just look here, 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 we could have this particular phytoplankton gets eaten by the clam, and then maybe the clam gets eaten by the octopus, and then the octopus gets eaten by the leopard seal. So again, these are showing food chains and food webs, but the big thing with it is also telling us how much energy is going, not just where the energy goes, but how much is moving around, okay? One of the things they talk about in here, and we'll get into this when we get to our do the math here in a second, is basically only 10% of the energy goes from one level to the next. So by that, what they mean is basically, let's say when this octopus eats the clam, the octopus needs to use a lot of that energy just to do things like we do, which is move around, breathe. They get oxygen from the water. We get oxygen from the air. We have blood that pumps around our body. So if we think about how we use energy, you guys use energy when you run around. Even digesting food uses energy. Using your brain uses a lot of energy. A lot of the energy we take in and eat is used just in our normal life processes. So it can't all be passed up to the next level. So again, when this octopus, it might eat a whole bunch of clams, but only some of that energy gets stored on its body, like muscles that build up or fat that builds up on your body, and it's not all available for the next level. So again, these life processes that happen, things need to move, things need to breathe, living things need to use a lot of energy, and so it doesn't all get stored on their body to go to the next level of the food chain, or in this case, the energy pyramid. So what I really like about energy pyramids is they start off really wide, meaning there's like more energy, and then as we go up, it gets narrower and narrower because there's less and less. So notice here, like this wide base, there's lots and lots of phytoplankton and other plant type organisms that provide lots of energy, and there's a whole lot of them. And then as we go up higher and higher, it becomes less and less. And that's why as we get to the top, there's fewer and fewer of these organisms because there's just not as much energy available. Okay, so that's kind of a big takeaway there. I'm actually going to go down here, and this is that do the math you see up here. I just kind of made it bigger up here. And this actually involves a pretty good connection with what we're doing in my math class right now, which is working with decimals and especially dividing decimals. Okay, so here we see an energy pyramid like we might see kind of in our more of our sort of area where we have grass. At the very bottom, grass would be our producer. Our first level consumer is the grasshoppers we see here, and these would be herbivores. And then the next level up, we see a snake. So maybe it's like a small snake that would eat the grasshoppers, and that would make this snake a second level consumer and a carnivore. And at the very top, we have an owl, and maybe that owl is going to hunt the snake. Again, the energy flows from the grass to the grasshopper to the snake to the owl. But the thing is, again, even the grass needs to use energy to do things like photosynthesis and to grow and maybe to produce grass seeds so it can kind of reproduce. And the same thing is true of the grasshoppers and the snakes and the owls. They're all using a lot of the energy that they take in. So when they eat, again, here it says 90% of the energy received from the lower level is used for what they're calling life processes here. Life process, again, just breathing, eating, moving, finding things. A lot of the energy gets used for that. And only 10% is available to be passed upwards. So that means basically stored on their body. So when those grasshoppers eat and grow, they use 90% of the energy they eat, but then 10% gets stored. So now we're going to do a little math here, and this is a great do the math section we see with this that we're going to talk about as we help understand how these energy pyramids work. And we can do this using decimal patterns, like we learned about a couple weeks ago now. I guess it was when we first started our remote learning experience in math class. So this actually has a really good math connection. And it's just going to be a simple dividing by powers of 10 and being able to rewrite decimals just by moving decimal points. This is all like a mental math thing. And on our quiz we're going to take later this week, I'm going to give you a situation where I tell you how much energy is at a certain level of the energy pyramid, and then you can figure out from there how things can go to find out the rest based on this idea of 10% being available. So when we say 10% of the energy is available, we can actually calculate that by dividing by 10. 10% is 1/10 of 100%. So if we think of just dividing by 10, that's how we can move from one level up to the next. So here it says if the grasses have 100 units of energy, how much can be passed to the grasshoppers? So what I'll do here, if we just kind of add to our diagram this first level here, where we've got our grass, I'm just going to put a 100 here so we can kind of see. I'll make it a little bigger so we can see better. We got 100 units of energy. Now we'll talk about calories, like when we eat food, we measure that, how much energy there is based on calories, and that's kind of what we're talking about here. But let's just say, okay, let's just call it an easy number like 100 calories for the grass plants. Now we need to figure out how much would get passed up to the grasshoppers. So the grasshoppers eat that food, but then some of it gets stored on their bodies and most of it gets used up. The way we can figure that out is by dividing by 10. Again, 10% is like dividing by 10 or multiplying by 1/10. And either way, that's just like a decimal problem, okay? So we're going to think, if I'm going to go up to my next level, I'm actually going to take, to find out how much energy goes up to that point, I can take how much I've got, which is 100, and I can multiply or divide. I'm going to, in this case, I'll say let's multiply by 1/10. It's the same as dividing by 10. So now, again, with these patterns, how this works, just think about, okay, well, if I did that, 1/10 of 100 or 100 divided by 10 would be 10, right? And so we can also look at it in the way of how we can move these decimals around. So if I had the number 100 here, my decimal point over here, if I move back one place in my decimal point, that would make it 10 and 0/10. So we'd have just this number 10 would be how much energy is available. Then we can continue that pattern all the way up. So first of all, our answer here, if the grasses have 100 units of energy, well, then there'd be 10 units of energy for the grasshoppers, because again, it decreases by 90%, only 10% gets passed on. So the next question is, why do the snakes only get 1 unit of energy? So let's start with that. If we go a step further, again, here we had 100 divided by 10 or times 1/10 would be 10 units of energy available. 100, then 10 for the next level. And then if we keep going that, we could say, okay, well, let's just think of it this way. If we just think the next level up, we have to divide by 10. So I'm going to do 10. This is like my division. 10 divided by 10 would equal, of course, 1 unit of energy. So there's only 1 unit of energy available. What we could say is, why is that? We could say that, well, the snakes are 2 levels up. We could say, we could use some vocabulary too, but the snakes are second level consumers. So there is 10% of the energy available from the first level consumers. And as we see, the first level consumers here are our grasshoppers. So again, it goes from 100 units of energy in the grass then to 10, then to 1. Now the challenge, the bonus, is what about this owl? And this helps us highlight and understand why it is that there's just not a whole lot of energy available for these top level consumers. If we have 1 divided by 10, hey, we're going to make a decimal or a fraction with that. If we have 1 unit of energy from the snakes, again, the snakes only have 1 unit of energy that they store on their body, and then there's only divided by 10 would be for the owl. That's going to be 0 and 1/10, okay? That, again, we would move a decimal from, now it's basically like we're doing 3 decimal places as we go through that there. So we're going to go from 1, and then here would be 2 for the second level consumers to the snake. And then as we go over to what's available for the owl, there's only 1/10 of the energy available from that what starts. So again, notice 100 is a lot of, if we think of that as far as what's available to the, or starting with the grass. By the time that energy flows through these other roles of the organisms, there's only a little bit available for the owl, and that explains why it is that we don't see a whole lot of owls or hawks or other things. We see lots of grasshoppers, and obviously you don't really think about it, but there's lots and lots of grass out there that's growing and able to provide energy for these parts of the ecosystem. Okay, so there's our one for the do the math. So hopefully again you follow along with that. Really, we're just moving decimal points. I could give you any number. I could give you a number like 57. And you could just move a decimal point, be 5 7/10, and then 0 and 57/100. It's just moving decimals. Okay, I'm going to real quick go to another one. This is one I sort of made myself that we can talk about, again, seeing these things in our own backyard. Here we have, we're going to build the pyramid, okay? So here we have the grass that might be growing in your backyard. And of course, there's lots and lots of grass, and there's other things there. I put acorns, squirrels, and a red hawk. You might see a lot of these things in your own neighborhood, and even in my own backyard, I see these things. And of course, there's other ones too, like bunnies and things like that. But if we have acorns, there might be lots and lots of acorns. Let's maybe make a few acorns we can kind of put down here with our other producers here with the grass. So you might see this and think about what would come next. What's going to eat those acorns, or what's going to maybe nibble on that grass? Would it be the hawk, or would it be the squirrel? Definitely it's going to be our squirrel, right? I heard there's one called Fat Luigi somewhere, so maybe this one's a little too skinny to be like Fat Luigi. But here we could have lots of squirrels, and you probably see lots and lots of squirrels in your neighborhood, right? So, but keep in mind, again, there's a lot more grass. If you think about grass as an organism, which it is, we see lots and lots more grass than we see squirrels around our neighborhood, even though we might see lots and lots of squirrels. Now, if you have hawks in your neighborhood, I see a few here and there. It's pretty fun to see them flying around, pretty neat, and you realize that we are in an ecosystem. There's an ecosystem happening around us, even in our city sort of suburb areas. That hawk might eat the squirrels, and they might hunt the bunnies and things like that too. And we're going to put them at the top, okay? So as we do this, again, notice you don't see as many hawks. You might see a couple. There's actually a nest in my neighborhood where they're raising a couple babies, but there's way more squirrels and rabbits and those things that it eats, not as many hawks, because as we go up this pyramid, and again, this is our big takeaway for today, as we go up this pyramid, there's less and less energy available. So again, that pyramid helps us see the shape of this. The wider it is at the bottom means there's more energy available. So if I make it my pyramid like this, we got our first level, which is our producer level, that has lots and lots of grass, lots and lots of plants, berries, flowers, all those producer things are all over the place. And then we have lots of first level consumers, which again, squirrels and rabbits and things like that. And the higher up we go to these predator levels, like hawks or owls or whatever it might be, there's just not enough energy for them. And again, that's because even the plants and the squirrels, when they eat up all that food, they're using up a lot of the energy. So the further we go up the food chain, there's actually less energy available. And this is why we don't see a whole lot of hawks as nearly as much as there are squirrels or rabbits and things like that. Or if we think about like in Africa, the savannas of Africa, you might have a pride of lions that's maybe a dozen or so, I think is a pretty large number. But they hunt herds of gazelle and wildebeest, and there's thousands of those, or zebra and things like that. And those zebra, and they eat these grass plants. Again, there's grass everywhere. There's so many grass plants around that there's plenty of energy for thousands of animals. But then the higher up we go to those predator levels, there's much less. There's less and less energy available. So that's our big thing there. Again, these energy pyramids show a food chain. So here we again have acorns to squirrels to the hawk. That's how the energy flows. But again, there's much less energy the higher up we go, which is why we don't see a whole lot of those predators And that's our big thing of the day. Okay, so again, hope you enjoyed this one. I'll talk to you soon. I got another one coming up later this week. We'll talk about that brain check, and we'll get ready for some quiz time. Okay, thanks guys. Have a good one. Go GA. See you soon.